Okay, today's lesson is over a couple of things, but the overall idea is we're going to talk about change expressed as a percent. So the main idea today is what we call percent change. So that's the first definition that you see up there. So percent change is the ratio of the amount of change to the original amount. So remember, when we talk about ratio, it just means a fraction. So we're going to be using this equation a lot today. Okay, so we've got this equation that says percent change equals, okay, and so the amount of change is going to go in the numerator. So amount of either increase or decrease. Sometimes it'll go up, sometimes it'll go down. In the denominator, and this is really, really important, it's the ratio of the amount of change to the original amount. So this is going to be the big idea here today, is that you have to have the original in the denominator. So when we're talking about quantities that are changing, so for example, the price of an item, if maybe the demand's going up, so the price goes up. What's going to go in the numerator is how much is that price increasing? Or if it's a sale, how much is that price decreasing? Okay, what's the dollar amount? And then the denominator, we're going to put the original. And then it's pretty simple. We're just going to divide it out and kind of go from there. So let's look at a couple examples. So it says, tell whether each percent is an increase or a decrease, then find the percent change, round to the nearest percent. So for this first one, let's say we've got an original amount that's 25, and then we've got a new amount that is 18. Okay, so first thing I want to decide if this is an increase or decrease. So if you think about something starts at $25 and it goes down to $18, this is clearly a decrease, so make sure you tell me which one it is. Okay, so then my next job is to actually find the percent increase or decrease. So to find the increase or decrease, I need to know two things. The first thing is I need to know the amount of increase or decrease. How much did it change? So from 25 to 18, that change was 7. If you're not sure how I got that, we just subtracted. Now in the denominator, and like I said, this is very, very important. You have to put the original amount. So we're going to take 7 over 28. Now all you're going to do is you're going to divide that out. So when you take 7 divided by 28, we should end up with 0.25. Okay, now my answer is supposed to be a percent. 0.25 is not a percent, that's a decimal. So kind of like yesterday, just change it to a percent, move that decimal 2 places to the right. So kind of two answers here. We're going to say that yes, it's a decrease, and then we're going to say that it decreased 25%. Okay, let's try another one of these. Number 2. Let's say this time I have the original is 15. The new is 17. So first thing, I need to decide if it's an increase or decrease. From 15 to 17, notice that this time that price was going up, or that amount was going up, so it's an increase. Then I need to find the actual percent of increase or decrease. So in the numerator, we're putting the amount of change. So from 15 to 17, it changed by 2. In the denominator, we're always going to put the original. So it's going to be 2 over 15. If you take 2 divided by 15, you're going to end up with 0.13 repeating. Now remember, that's not a percent, that's a decimal. So to change it to a percent, move the decimal 2 places to the right, which is going to be 13.3 repeating percent. But we want to round to the nearest percent. So we'd look at the 3. Okay, the 3 tells me I need to stay at 13, so my answer would just be 13%. Let's try just a couple more of these. Okay, number 3. This time we've got an original that is 45. We've got the new amount is 60. Okay, so first thing, from 45 to 60, that is going up, so we would call that an increase. And then to find the percent of change, I need the amount of change. So from 45 to 60, if you take 60 minus 45, you get 15. I want you to notice that I'm kind of disregarding the sign. I just want to know simply how much did it change. And then in the denominator, like I said, we always put the original. And then when you take 15 and divide it by 45, you're going to end up getting 0.3 repeating. Okay, now I need to change that to a percent. So make sure you move the decimal 2 places to the right. So you're going to get 33.3 repeating percent. And we want to round to the nearest percent. So kind of like the last one, we're going to stay at 33. Okay, and then the last one of these, let's say we've got the original is 95 and the new is 90. Okay, so from 95 to 90, that's going down, so we'll call that a decrease. To find the percent of change, the amount of change, it changed by 5 from 95 to 90. And the denominator, always remember, you have to put the original. So, and then if we take 5 divided by 95, it's going to end up being 0.0526, whatever. Okay, so now I need to change that to a percent, so move the decimal 2 places to the right. So we end up getting 5.2%, but once again, round to the nearest percent, so we'll just chop off that 2 there. The other thing that this lesson talks about is what's called relative error. Now, it's a very similar idea, but this talks about if you make an estimation and your estimation is a little bit off. It talks about, well, how far off were you? What percent off were you from the actual value? So relative error is going to also be a ratio, okay? And this time, it's the ratio of the absolute value of the difference of the measured and actual value to the actual value. So it sounds kind of complicated, but really, here's what we're going to do, is we're going to take the absolute value, and we're going to take the measured or the estimated value. So sometimes we're going to measure, sometimes we're going to estimate, minus the actual value. Now the reason why we're going to take the absolute value is I always want that to be positive, and sometimes your measured or estimated value is going to be bigger than the actual value, sometimes it's going to be smaller. So kind of like in the last one, I really just want to know, well, what's the difference between those two? We're going to disregard the sign. And then in the denominator, we are going to write the actual value, so what it actually ended up being. So these ones are going to look kind of like this. So number 5, let's say that you estimate a tree is 45 feet tall, okay? Now, it is actually 58 feet tall, okay? So I look at it, I decide, you know what, I think it looks about 48 feet tall. Well, then I find out that it's actually 15 feet tall. So to find the relative error in the numerator, like I said, it's kind of like percent of change. I'm looking for the distance. What was the difference between my measured or my estimation and then the actual value? So the difference between 45 and 58 is 13. And then kind of like with the percent change, it's really important what goes in the denominator. The denominator is going to be the actual value. Well, the tree was actually 58 feet tall, so that's what we're going to use for my denominator. And then just like before, if you take 13 divided by 58, you're going to end up with 0.224. It's going to continue on, but we don't want a decimal, we want a percent, so that's going to be 22.4%. That 4 is not quite big enough to kick it up, so we're going to leave it at 22%. Okay, so let's try one more of these. So this time, let's say a carpenter estimates a wall to be 20 feet, but it is actually 18 feet. Okay, so for relative error in that numerator, just like percent change, what was the difference? What was the difference between what I thought it was and what it actually was? Well, between 20 and 18, that was going to be 2. In the denominator, we're going to put the actual value, so what it actually was. And the actual value was 18, so we're going to take 2 divided by 18, and we're going to get 0.1, and it's going to repeat. So when we change that to a percent, we're going to end up with 11%. Okay, now the last thing we're going to be doing today, and this is kind of a random thing. It's pretty simple. It says a measurement is given. I want to find the minimum and maximum measurement. So we'll kind of talk through this first one. Okay, so it says that we have a patient that weighs 178 pounds. And I want to find the minimum and maximum measurements to the nearest quarter pound. Now what this means is, let's say, okay, so I'm a doctor and this patient is supposed to weigh 178 pounds. Well, if I want to say exactly 178 pounds on the dot, that's going to be really hard to do. So I'm going to give them, well, a quarter pound, okay? Now, it's not a quarter pound on either side, however. It's a quarter pound between the minimum and maximum, okay? So what we end up having to do is I need to find the minimum that they could be and the maximum that they could be. Now, what it means when it says that I want their weight to be to the nearest quarter pound, I want it to be to the nearest quarter pound between my minimum and maximum. So what I have to do is I'm going to take that quarter pound, okay, which is 0.25, right? And I'm going to divide it by 2, okay? So stay with me here. Whenever you take 0.25 and divide it by 2, you end up with 0.125. So if the minimum weight, how you're going to find this is you're going to take the goal weight, which is 178, and they could be, well, minus 0.125 pounds, okay? That would be half of my allowance, which would be 177.875 pounds. So that's the minimum weight that I could do. And then I'm going to do the same thing with the maximum weight. Well, they could have the 178 plus that 0.125 pounds, which is going to end up being 178.125 pounds. So what I want you to notice is that the difference between these two numbers, between 177.875 and 178.125, that's a quarter pound. Okay, so I'm kind of giving them a quarter pound leeway, but it does not mean a quarter pound on either side. It means a quarter pound total. Okay, so let's try one more of those. Okay, this one, we've got a board, so maybe a carpenter again. Okay, a board is cut to 28 inches, but to the nearest ½ inch. Okay, so I really want this board cut to 28 inches, but I'll give you a ½ inch, once again, not a ½ inch shorter or a ½ inch longer, just a ½ inch total. Those are that's your minimum or maximum. So first thing, if I can have a ½ inch total, I've got kind of two ends here. It could be shorter than 28 or it could be longer than 28. So if you take ½ an inch and divide it by 2, you're going to end up with 0.25. So that means that you could take that 28 inches and it could be a ½ inch short, or it could be a ½ inch long. So to find the minimum measurements, you're going to take your goal, which is 28 inches, and you're going to subtract that ½ inch that we said it could be, which is going to give you 27.75 inches. Okay, so that's going to be your minimum. And do the same thing with your maximum, except, well, I'm saying, well, it could be 28 inches plus that 0.25, which is going to end up giving you 28.25 inches. So once again, the big thing you have to remember here is when it says, you know, they'll give you ½ an inch, it doesn't mean ½ an inch on the lower end and ½ an inch on the bigger end. It means a ½ an inch total. And once again, if you notice, the difference between my minimum and maximum is going to end up being ½ an inch.